first talk today is Jared from Upbound, founding engineer, to talk about Crossplane. I think this is a really neat product and a different approach to InfraCode. So I'm really excited to hear this. Welcome, Jared.
Awesome. Thank you so much for having me today, Finn. It's good to see you here in this context, be part of the festivities today. So
I'm excited about it.
Yeah, cool. Let me go ahead and share my screen and get that going for us. So I want to do an entire screen so we don't miss out on anything. So let's go ahead and share that and let that come through the feed here. There they are. All right, sweet. Okay,
take it away.
So great, Finn. Thanks for the introduction. I don't need to introduce myself anymore, but we're going to be talking about Crossplane today. And Crossplane has a lot of different sort of a spectrum of functionality. And so we're going to go through a demo for each phases of the spectrum there and kind of teach you all how to get the most out of it that you can. All right, so first one here. Everyone on the call might not know what Crossplane is, so let's just do some definitions first. Crossplane, the way to think about it is that it is a cloud-native control plane. You can use it to basically provision and manage all of your cloud resources. That's the goal with it. That's nice, but the better functionality that Crossplane really shines with is you can compose those resources together into higher level abstractions that then allow your developers, your app teams to get the infrastructure they need in a kind of self-service basis. Control planes, not a new idea, right? We all are pretty familiar with Kubernetes here. Kubernetes is an awesome control plane for containers. So Crossplane basically extends Kubernetes and then teaches it how to manage everything besides containers, everything else, right? There's a lot of other stuff out there besides containers. And then, of course, control planes have been used for years, decades. So they're not a new concept here, but the Crossplane basically helps you build your own. Okay. So I said we're going to be talking about a spectrum of functionality in Crossplane. Here's the little quick visualization of that spectrum and mapping to the 4 different demos that we're going to give here today. So we're going to start with the leaf resources, these small granular managed resources for everything in the cloud. We're going to do something with that. We're going to start composing them together into higher level abstractions. We're going to start getting higher level config language type of experiences on top of that. And then we're going to write some full on general purpose programming language code. So we're going to see a whole spectrum of functionality here. And we're going to get started with the first one, the basics, managed resources. So what is a managed resource in Crossplane? It's basically, you can think of it as a representation of external resources that live outside the cluster in cloud providers or on premises, stuff like that. The AWS provider, for example, there's over 900 different resources that it supports. So, all these useful services there. There is a representation in your Kubernetes API for all of those. Of course, as Finn already mentioned, actually, there is a Crossplane provider for Equinix as well. I know Marcus Johansson did a lot of the heavy lifting on that provider. So thank you, Marcus, for getting that done. And hopefully we'll be seeing each other in KubeCon or something soon. So there's a Crossplane provider for Equinix as well. And so what does this look like, these managed resources? So you can think of them kind of as an extension to the Kubernetes API. And so, you've got pods, deployments, config maps, stuff like that. Now there's all these hundreds or thousands actually of additions or extensions to the Kubernetes API that represent real world infrastructure. So for example, here's one for an S3 bucket. You can see that you get like a declarative experience, YAML config here to specify some configuration options for that bucket. And then Crossplane will go make that happen out there in the real world. Like any good Kubernetes API object, you'll see that they have, spec and status. You can see the health of the resource and different conditions and such in the status. You can see events that tell a story of the provisioning and management and lifecycle and whatnot. So, they're well-behaved, nice conformed Kubernetes API objects, all of these thousands of ones for all the resources out there. And then how does that work under the covers? Probably like you expect. You're starting from the left side of the graph here, you can declaratively apply a manifest, probably through GitOps, but you could do it directly with like kubectl or whatever. Apply that to your cluster, to the API server. There's a bunch of controllers in Crossplane that are running and watching for events and the API server. The S3 controller specifically will see that there's a create event for this bucket, and then it will go and reconcile that desired state with the actual state of the real world and use the AWS APIs to talk to AWS and make that bucket happen out there in the real world. So that's enough slides for now. We have 4 demos to get to. Got to start doing them soon. Let's go to the first demo. All right. So first thing to look at here, we've got this VPC. This is like we are in all of these demos, we're basically going to be creating network infrastructure, and we're going to be doing it in 4 different ways to get progressively more and more functionality. This is the most simple one, right? So this isn't going to be super impressive because we're starting with square one here. So let's just look at the most basic functionality. I've got a VPC here. Specifying some configuration like what region to put it in and blah, blah, blah. I've got another VPC that I'm going to create as well. So 2 VPCs. I've got an internet gateway here. All these YAML manifests that I'm going to apply directly to the control plane. And with the specification, like for instance, this gateway is going to use a selector to find the VPC that it's supposed to be wired up to. Crossplane will make that happen for us. So we're declaratively creating these resources with YAML config. Not super exciting, I know that, but we're going to do it anyway so we can see it work, right? So disregard my little cheat sheet readmes. I don't like to type during live demos because I can't do it very well. So copy and paste as much as possible. But basically, we can see here now that we've applied those manifests, and then out there in the real world, we are going to start to see things happen. So Crossplane is, got the events for, okay, you asked for VPs or 2 VPCs, 2 gateways. I'm going to go and talk to the AWS API and make that happen out there in the real world. So we can keep seeing some progress. That's where we're going along there. So the VPCs are created, they're synced, they're ready, they're happy. One of the gateways is ready and wired up to its VPC. The other one's not quite there yet. But so we can start seeing like some more of the details here. So let's look at, for instance, the full spec and status. I'm asking the API server to give me this gateway object, and you can see like all the config that we specified. Crossplane has gone ahead and found through that label selector, found the VPC to wire it up to, the VPC ID, it inserted it into the spec for us. You can see the status conditions, that things are healthy and happy, and then we can also kind of get some of the story here through events as well. So I'm going to describe. Oops. You know what? This is why I don't type in demos, but just copy and paste again. So we can see here that we've got events for this this gateway object as well, right? We see that Crossplane went ahead and tried to create it. That was successful. It was trying to resolve the references, and it was not finding it at first because it was waiting for the VPC to come online. It found it eventually. Everything's happy now. So we've applied directly YAML resources to the control plane. The control plane went out on our behalf, made that happen in the real world. That is cool. That is good. But not that interesting, as we said, right? Because there are some downsides to doing this directly. First, there's no abstraction here, right? If you want a platform that is going to provide self-service resources to your developers, then they're basically getting everything exposed to them. They have all the complexity, they have all the power, you have to have write access to these resources. You may as well just give them access to the cloud console and let them party there because they can do basically anything with this, right? So, and there's no logic, there's no expressiveness, no programmability to it. It's not great for building a platform, which is fine because Crossplane superpower is not these managed resources. Crossplane superpower is being able to compose these resources together into higher level abstractions and build a platform out of them. So what does that look like? So for example, you can take together a GKE, node pool, networking stuff, and then compose that together into a kind of a cluster abstraction, right? And this provides kind of an infrastructure platform API that lets your developers self-service, kind of gives them a subset of configuration that you want them to be able to work with. So it reduces that complexity, strong separation of concerns. And since we're only at stop 2 of the 4-stop tour of the spectrum of functionality here, we can still do this declaratively and without any code at all. So let's see kind of a picture of what that looks like. Starting from the left here, we've got a developer. She needs some infrastructure. She needs some cloud resources. So she can submit a simple claim, that simple abstraction that we provided to her. Underneath the covers on this side of the line, the right side of the line, we've gone ahead as a platform engineer. We've defined that API, the shape of it, what is the abstraction here we're providing for them. And then we can have multiple at runtime implementations of that abstraction. So multiple compositions. How do you compose these resources together under the covers? What does that look like with the practical example? Well, say we defined an API for databases for our developers so that they can self-service and get a database when they need one. So our developer here, she says, hey, I want a small Postgres. That's kind of all she has to really be thinking about there. Maybe a couple of config options under the covers. we as the platform engineer have defined this API, defined the definition of what she can, be exposed to there. And then there, for instance, is an AWS composition that has RDS, DB, perimeter groups, security groups, stuff like that. It doesn't have to be just cloud providers, right? Like you could have AWS, GCP, Equinix, whatever. You could also do other abstraction type of stuff like gold and silver, or fast and slow, or cheap and expensive, whatever. It's your choice as a platform engineer, like what type of platform you're building and what you need to do for your organization. So second demo, let's jump into the second demo now. I'm going to close up all this stuff here so I don't get confused. And we're going to jump into the second demo. All right, so we've got to define a platform here for our users now. I'm going to wait for the stream to catch up. There you go. So maybe make this a little bigger.
Not sure if I'm heard. Hey, are you able to zoom in the text a little bit?
Yeah, I just did one extra.
You could do like one or two more, be perfect.
Yeah. Is that getting good there, then? All right, sweet. I'll do the same on the CLI. Cool.
Thank you.
All right. So so we are defining a network abstraction for our users. And we basically, kind of define what are the properties that they can set there. What does this API look like? So they can say they can give it an ID for their network. They can give like a count of how many network stuff they want. Yes, Boolean if they want to include the gateway or not. So this is kind of defining the API for them. And then underneath the covers, we've got to define like how do we actually compose this? What's the runtime implementation here? So we've got a set of of resources that will be composed together. So this is, kind of a lot of YAML here, but we're only at step 2, right? So we're going to keep improving as we go. So in this composition for the network abstraction, I'm telling Crossplane to go ahead and stick together a VPC resource. And here's the spec for it. And then go ahead and stick together a gateway resource as well. And here's the spec for that also. Then we need to get the configuration from the user somehow, right? So the basic way in Crossplane to do that is with patching and transforming. So we can say, here's a set of patches that takes data from what the user has provided on their simplified abstraction. And then this is like how you patch it, how you transform it, how you get it down into the underlying resources. We're going to see ways to improve on this, obviously, later on. But this is the core concept of composition in Crossplane, where you're specifying what resources do I compose together at runtime, and how do I get data from the user, right? So let's go ahead and start applying this stuff to the control plane. So we're going to define. Let's make this one bigger as well. All right, so we're going to define the API. We're going to define the composition. That's on the control plane. That's all good. So we should be able to see that we've extended our control plane now with this new network abstraction. And so now our developers would be able to go ahead and create these claims. They can say, hey, I want one network here, or I want a network with ID 1, and I want it to be in this particular region. And I want another network with a different ID in this particular region. And so the developer here basically gets that simplified experience instead of working directly with those granular managed resources, right? Now they're just working with these simplified claims, a simplified abstraction. And then at the end of the day, they will still get their resources that they're requesting, but we're doing it through an abstraction. We're actually starting to build a real platform now here, right? So Crossplane is going and doing that work now. It is, for each of the network abstractions that the user requested, underneath the covers, it's creating a VPC, it's creating an internet gateway, it's wiring those up together, it's reconciling them and making sure that they're kind of driving towards being healthy and ready for them. So we can see the VPCs are done now. The gateways are still working, but right. So we're kind of getting a platform here together to expose network stuff to our developers to self-service. So that's good. That's an improvement, but I would not say that we are at an ideal yet, right? We've still got some downsides. So cool. We've got this abstraction. Developers can self-service. That's good. But there's a couple issues here. One is that this is kind of difficult to test. You saw here that we're kind of using this by applying them to cloud and letting like real stuff happen out there in the real world. That is if you want to kind of test and make sure your logic is working well, that's not super efficient, right? Because you got to like wait for it to spin up. Did it not work? Oh, it didn't work. Okay, I'm going to change some stuff. I'm going to try again. The cycles are long, right? The amount of things you can do is pretty constrained with patch and transform. You can patch and you can transform. That's not like a full programming language, so there's better. We can do better than that, right? So let's move on then to the next stop on our 4-stop tour. We're halfway through, so I think we're doing good time-wise. So functions in Crossplane are pretty sweet. They're pretty awesome, and they let you start having higher level experiences. So we talked about the deficiencies with classic composition in Crossplane. And, we can see that we basically can't do much with it, right? We can't do any interesting logic. Composition is not a programming language. Just doesn't let us do more interesting stuff. So how do we solve that? In Crossplane, we've got a concept of functions now. So basically with Crossplane's functions, you can run a pipeline of simple functions that do different type of activities. And that's how you compose resources together, as opposed to just like specifying the resources and how to patch and transfer them. You can kind of start using some arbitrary experiences and real logic and stuff like that. We're trying to find this sweet spot in between, writing a whole controller with controller runtime stuff and kube builder or whatever, and that completely no code, all declarative, direct resource type of thing. We're trying to find a sweet spot here where you can focus on your organization's logic and the experience you want to have, but still accomplish the task and build the platform you want. So we're at stop 3 here. So we're going to be using higher level experiences, but we're not to general purpose programming languages yet. So we're going to look at like templating and, like config languagey type of stuff is really where we're at on this 3rd stop here, which means another demo. All right, so let's start clearing stuff up on the screen here again. Go to the 3rd demo. All right, so the first thing we need to do is we need to install some, no, I'm in the wrong directory. So let's do number 3 and then apply the functions. So basically I'm going to say, hey, I like KCL. I've heard about this KCL. I thought it stood for Kubernetes config language. I don't think that's actually true, but like it's kind of a config language that works really good for Kubernetes. So in my mind, that's still the case. But I'm going to install a function that knows how to do KCL stuff. And then I'm going to then write a composition that basically the same network abstraction we've been dealing with, I'm going to write a new runtime implementation for it that uses KCL and functions. So there's a lot of stuff on the screen, yes, but we're still at the 3rd stop of the tour. So for that network abstraction, I'm saying run a pipeline of functions. And this very first function here, the very first step in the pipeline is run the KCL function, please. And now here, awesome, I get an experience in KCL. I can start using this particular language that I've chosen for the demo today to programmatically build up resources, compose them together, take data from the user, and put it down into those resources. So we start getting a higher level experience here. We'll look at some details in just a second, but let me kick this off for us. So we should have the KCL function. Yep, it's installed and ready, and we've extended our control plane with that type of knowledge and functionality. And then we've got to apply our new composition that uses KCL. And then now, as a developer here, basically, I'm going to kick off 2 new claims here. Okay, so one of these claims is basically, with our network abstraction saying, yes, give me, I want 2 networky stuff. And yes, do please true, include a gateway object for me, put it into this region. And then I'll create another one that says, oh, just create one underlying network resource for me this time, and don't include the gateway. I don't want that this time. And so then our composition would kick in, and our logic, our custom logic in KCL can run. And we can see here, it might be a lot to parse here, but we'll look at the critical element here is that we're creating a set of VPCs, and we're doing some flow control stuff now, right? You cannot do this with patching and transforming simplified logic. We're doing flow control stuff for up to count times. Create VPC objects for me, please. And then here's the specifications for them, and I can start doing string.formatting stuff to take information from the user and embed it down in there, etc. Similarly with the internet gateways here, I'll create a collection of those for up to count times, but then this is conditional. only if they want the gateway will I do this. So we're starting to do higher level experiences and flow control and conditionals and stuff like that. So that's pretty nice. And now let's look at, we kicked that off. So we should start seeing those happen in the real world. Our KCL function should be running, it should be executing, and most of it's done now. So this network object here where I said just one and don't include the gateway, that's done. The one VPC is created. This other one's almost done. I said I wanted 2 network resources in there, please. There's 2 gateways, there's 2 VPCs, and I did say yes, include the gateway also. So we're giving the developer more control by underneath in our platform using a higher level language experience, right? So let's move on then to the last stop on the tour. Or actually, let's tell you why functions are great one more time. So yeah, you can start using higher level languages here. There's lots of different ones. We focused on KCL, but there's one for like Q, there's one for templates, there's one for Pickle that's pretty new as well. There's lots of different experiences you can have here. Choose the one that works best for you, right? All right, final stop on the tour. So if you want to write full code with general purpose programming languages, you can do that as well. Full code, full power, do whatever you want. All right, so maybe there's not a reusable function for what you want. If you have some niche logic in your organization that's kind of weird, you can do whatever you want with a full-on programming language. And then along with that comes all of the tooling that you might be used to, linters and static analysis and unit tests and all that great stuff. If you choose to use a full programming language, you also get extra Crossplane functionality that you can kind of only access when you're doing things, with the full language. We have a couple SDKs here that help you kind of get started with it. So you can use any language really, but there's helper functions and libraries and stuff in the SDK for both Go and for Python that will definitely make that journey, simplified and easier for you. So let's look at full code now, see what that kind of thing looks like. All right, let's close this off here. Let's clean up a little bit around here and go to the 4th demo. All right, so this is a demo about code. So I got another source code. That might be a little too big. So let's try to find a balance here between big enough to read and not overwhelming. All right, so we've got real code. I chose it to write it in Go. I am not a Python person, so that might have been a more challenging task for me to do. So I use Go. But basically, we are going to use all the things that you may like about Go, if you're a Go programmer, to do the similar task to what we've kind of been showing in the previous stops on our tour so far. So basically, with Go, I can access, the user's config object, their simplified abstraction. I've got that. Now I can start pulling and retrieving some of the config off of it, like the count and, bool to include the gateway or not, what region, etc. And then I can start using, this full programming language here to dynamically compose resources together and configure them and such. So, for doing a simple for loop here in Go, we're going up to count number of times, and then programmatically I'll create VPC objects. Now, the thing that's really nice here, right, is that we're in an IDE. We have a statically compiled, strong typed full programming language. So, if I made a mistake, that we could be checked by the compiler, well, the compiler is going to let us know immediately. It's like, no, there's no field called foo. What are you doing? I know this type. I know all of its structure and values and schema and stuff. You can't do that. So that's quite a nice experience to be able to start programming and use a full programming language here, right? It's very, very nice. Similarly, we'll do the same thing for gateways, and conditionally, if we need to include the gateway object, we can go ahead and do that. We'll create it, using the strongly typed gateway object or struct in Go, and so we're using a full programming language here, right? And we'll add those resources to the set of desired resources that we'll tell Crossplane about, and then Crossplane will go do the rest of the heavy lifting to make those happen in the real world. So since this is programming language, we can do cool stuff like testing. That's nice, right? We can start verifying this functionality and see if it actually works. So I want to make this bigger here. And then I think this other one I want to make bigger as well. Should have had all these bigger before I started, but here we are together. Okay, so let's start trying to actually run this thing locally. This is a huge difference from the way that things used to be in Crossplane, right? Where you would apply them to the real world and test to see what happens that way. Now I'm going to just say go run, and this is basically starting, like there's nothing to really see on the screen because the function is running in the background. But the function has now started up, it's been compiled, it's running, it's waiting for commands and such. And then we can do something such as, we could say, it's like a little test here. We could say, hey, here's a network abstraction. Just do one of the network resources. Yes, include the gateway. And then see what happens with the output there. So let's run that real quick. I know I'm bouncing around a lot, but appreciate everybody bearing with it here. So we basically use the Crossplane render command and to talk to our function that's up and running, give it some input, and voila, we have output. We've got an internet gateway. We've got a VPC. We can see that these values look reasonable. So this is like a kind of a big leap forward, right? Where this is all on my local laptop. We're not doing things out in the real world. We are rapidly iterating, testing, seeing if it's working, making changes, getting feedback like in less than a minute, right? We're rapidly iterating on this stuff. So if you've used Crossplane to build stuff in the past and had like a tough time kind of, with slow iteration cycles, check it out now again, use functions, and you can do things a lot faster. I'm showing this for the full code, but you can also do the same type of functionality for like KCL and Q and Pickle and stuff like that, right? If you're using functions in Crossplane, then you can do this, local testing development loop, which is really, really nice. Another way to test is with unit tests, right? So here's Go. I'm going to write some table-driven tests in Go. Some people hate that. I particularly find them to be quite nice and satisfying. So here I have a unit test that does kind of the same thing. We're verifying our functionality. We have a test case for creating one network. And so given this input of, the network abstraction and a count of one and including the gateway, then we expect or we want to have this particular output from our function of a VPC with this particular configuration and a gateway with that configuration. So we've got unit tests that we can actually verify and protect ourselves from regressions and stuff. So let's kill the function that was running there and run our Go test, using our native tools to do testing, unit testing, static analysis, all that stuff. Cool, we got 61% code coverage as well. Not bad for a single test case, I'd say. But we're verifying that this stuff works, and we still haven't touched the real world, right? So now let's go ahead and wrap this thing up by touching the real world and actually, we verified it enough locally. Let's see that it actually works out there in the real world as well. So let's do this here where we have to, yet again, oh, nope, this is going to be the wrong directory. So let's go to demo 4. Okay, and then we're going to go ahead and apply the functions here. So we're saying this network function that I wrote in Go, please install that into the control plane. So that should be there up and ready waiting for us. And then we're going to install a new composition as well. And that composition is much more simple now here. We're saying for that same network abstraction we've seen many times so far, this is all you have to do, Crossplane. Just run this pipeline of functions that is like the Go function that I wrote to compose network stuff together. Just run that. And then run another second little function here to just kind of test that the resources are ready. Very simple. Not a lot of YAML going on here because we put a lot of that logic into, Go, compiled language, binary, in a container, blah, blah, blah. So does this thing actually work? It should work because I've tested it before. We tested it locally as well. So let's once again go ahead and create a claim as the user, creating a network resource, requesting 2 of the underlying network stuff. Yes, saying true for the gateway, putting it into this region, simplified abstraction for network stuff. I created it, and it should be off and working now. So if we use the Crossplane CLI to just query the Kubernetes API, we can see that, cool, stuff is happening there. I requested the network resource stuff. I got 2 VPCs, 2 gateways. Things are happening. They'll reconcile, they'll keep reconciling, they'll get all the way to ready as soon as Amazon says they are. We are happy here. So wrap this thing up here. If you need full code, full power, use it. You can do this in Crossplane. Use a general purpose programming language, have the native tooling experience, get a great developer feedback loop for test early, test often. This is what you can do with Crossplane now, and it's quite nice. So we have looked at all 4 stops on the tour. We are done with our tour. We started with managed resources of directly applying configuration YAML for every single resource to the control plane. We started composing those together into abstractions for our developers to have a nice infrastructure API. We started using higher level experiences with functions. And then we wrote general purpose full code to do very specific, expressive, flexible stuff. The end, Crossplane is a CNCF project, so we're applying for graduation right now. So everyone's support on that is super helpful. And then the main site to remember is crossplane.io if you want to go check out basically everything else to join us and be part of the community. So thank you so much.
And thank you. That was wonderful. I tried out Crossplane, I think, earlier this year, and I thought it was really cool. So that was nice to see it all laid out as opposed to my like very early demo stuff. I also thought KCL was Kubernetes config language, so now I guess we'll have to figure out what that actually is.
Yeah, we could ask.
I was trying to like Google it in the background, and everything just said KCL. I was like, that's not helpful. But yeah, I think the big thing I want to leave with here, we're a bit behind, so we're not going to do too much Q&A, but is there a succinct, like, what do you see as Crossplane as like really sets it apart from like Pulumi or Terraform that tend to run more local versus like leveraging the Kubernetes control plane?
Yeah, great question, Finn. So I think that like the 2 things I would think of right away is that, the properties of the Kubernetes control plane where you've got active reconciliation and, you're kind of like making sure that things are as you desired state expressed that you want them to be. So if things go out and, drift in the cloud there, somebody changes things directly, then that's just part of what you get out of the box is that Crossplane will fix that for you and, reconcile that drift. And the other thing that we talked about a lot in the demos there is that, Crossplane is great for building a platform, for providing an experience to your developers where, you're not giving them direct access. You're not having like them have to write specific code or do anything. You're giving them nice simplified abstractions, kind of that separation of concerns and self-service and stuff. And that's kind of just part of the basic functionality of Crossplane as well that kind of separates maybe from other type of experiences.
Nice. So leveraging the complexity you've kind of already got in your system to do more complex stuff. I like that.
Yeah.
Awesome. Well, thank you again so much, and hope you have a great rest of your day. Join us maybe for the rest of our demos.
Yeah, I'm sticking around. Thanks, Ben.
Awesome.